Welcome to the third part of my waste oil burning water heater build series. In the last video, we finished the construction of the combustion chamber. We were even able to get a test burn going to see how well the design is going to work. I'd say the concept is pretty solid and it seems to work quite well. We got some really nice high combustion temperatures. I think it was 800, 900 degrees Fahrenheit, somewhere in there, so that's really promising, considering that this is a naturally aspirated burner, so there's no auxiliary fan to force air into it. It's just feeding the flame naturally with the draft from the long flue that we have set up here. One thing that I would like to move on towards is, as you can see here, I have this car tire rim as a base, and I'd like to get that combustion chamber attached to that rim, just so that there's a little bit more stability in the overall design. Once we go to put the water jacket on top here and it's full of water, without that base, this would be quite top heavy, and there is a risk of it falling over, and having something full of boiling hot water running at 800 or 900 degrees Fahrenheit would be really no bueno. So I would like to get that attached to the combustion chamber, and then once we're done that, I'm going to move on to fabricating the water jacket for the water heater portion of this build. That's what I ended up doing to attach the bottom of the combustion chamber tank to the actual wheel rim. And so on the back side of the piece of, I don't know, call it flat, for the bottom of the tank, I welded a nut so that all you have to do is just thread in that 5/16 bolt, and the nut is already captive on the back side. So no monkeying around to try and get that to fit. It just will go straight in, piece of cake. So that is more or less the base. Moving on to the water jacket, I've marked out the locations for these weld-in threaded inserts. And so going from the top, this is our relief valve. That's a 1/2 inch. We're gonna have a 1/2 inch opening for the thermal well, for the temperature controller, a 1/2 inch drain at the bottom. We're going to have a water inlet and a water outlet. These are 3/4 inch. And then over here I have a 1500 watt electric heating element and a 1 inch threaded insert. So the purpose of that is to be able to shut the burner off but still have maintenance heat to keep the system above zero, above freezing, without having to run the oil heater. So it will cycle on and off at a lower temperature rather than the one that we're using for the hot water. Now, to punch these out, I'm going to drill just a smaller hole first of all, and then use this hydraulic knockout set. This will make for nice clean holes and make for easy making of those holes. Well, the punch made really short work of getting those holes done, and it leaves a really nice clean hole. And fortunately, the dies that I have match up with these weld-in steel inserts perfectly. So once I got them punched, I actually used that punch kit to seat these in place, to press them in. So these ones are already pressed in place, as well as that one. So that's the inlet, outlet. This is for the auxiliary heater. And there will be a 1/2 inch one there, a 1/2 inch one down there, and a 1/2 inch one there. So that'll be the drain, that'll be the relief valve, and this will be the thermal well for the temperature controller. So I'm going to get those welded in, and then the next step will be getting this thing cleaned out so that we can get it on top of the combustion chamber. Well, we have all of those welded in place, and all the welds look really good. I feel quite good about them not leaking. So I'm just letting this cool, and I am going to clean it out, get all of the metal debris out, and get it ready so we can marry it onto the top of the combustion chamber. And so what I did is I just laid an additional bead around there. The first one looked really good, but I mean, what's better than one? Well, two. So hopefully that extra bead there is a little bit of an insurance policy to keep it sealed around there. And really the reason I did that is because once the water jacket is attached to this, it is going to be darn near impossible to touch up any welds. I'd have to go somehow through the door, have this flipped upside down. It'd be just a big pain in the butt. So gonna just hope that that's good. Any of the other welds I can access from the outside, so that's no big deal. All right, well, I have the water jacket sitting on top of the combustion chamber. Everything's ready to go. I've cleaned up all the surfaces for welding, and yeah, it's time to put these two together and make it one. There we go. We have the two sections of the water heater put together now, and I think the next step is to get a couple plugs to block off some of these ports, and we will see if we can get a little bit of compressed air in there just to see if we can do a little bit of a leak test. Not a lot of pressure, maybe 5-10 psi most, and a little bit of leak detect should do the trick. So while I get that set up, this could cool down. We'll get that ready and we'll see how we did. Well, I cannot say that this was a perfect job. I did the leak test. I just set up a air inlet there, so all these arrows, so that one there, 2, 3 up there, 4, 5, 6, 7, 8. That's good. 9, 10, 11. I think that's about 12 holes in all that I need to repair. All pinholes, obviously, nothing major or gaping. So, yeah, I don't know. It's about what I expected, really. Hope for the best, and my confidence on the interior weld is marginal. I cannot believe that it is perfectly sealed, so I will touch up these and we'll continue to leak test, and I will spray some of the leak detect on the inside, and we'll see what we get. All right, well, I've managed to get all of these little leaks around here sealed. I used the more on technique. If it's leaking, just put more on. So that is done. So next, I put a little bit of leak detect on around the flue inside there, and I'm gonna say it's no bueno. There are, I'm gonna say, at least 2, maybe 3 leaks around there, which is kind of disappointing. So I need to come up with a plan on how to get in there and weld it from this side of the combustion chamber. Well, in no way does this please me, but welding through the opening, as you can see, was just a pain in the butt. So went ahead and cut the bottom off. We'll have to just re-weld it. No big deal. No big deal. So now I can address the leaks around that seam there and get this taken care of. We'll weld it back together. Well, I managed to get that sealed up. wasn't exactly easy. I ended up doing 2 complete passes around, overlapping, and then another pass over top of the edge of the tube, and then there was one little pinhole here that I chased around for a couple minutes. Finally got that sealed up, good to go, and now I'm going to get the bottom part of the combustion chamber reattached, and that should conclude the welding of the water jacket. It should be watertight, 99.9% sure of that. Yeah. So anyway, glad to have that taken care of. It would have been impossible to do it with the bottom on. Hindsight, if I could have come up with some way to pressure test that weld before I put the water compartment on, that would have been great, but I don't know how I could have possibly done that. So yeah, this is the next best thing. I'm gonna go ahead and get the bottom half reattached, and we should be done here. Back together, and to my delight, the door still fits perfectly. So that is a really nice thing to see. So overall, yeah, that was a pain in the ass. But it's done. It should be ready to hold water. And yeah, I'm looking forward to doing exactly that. So I will give it a coat of paint with some high temperature spray paint, and then I will fill it up with water, and we will do a test fire, and hopefully it doesn't start any leaks. Hopefully it stays exactly the way it is, and we don't run into any issues. So that will be the next part. Well, here we are. We have the painted unit. It's dried overnight, and it is ready to get started again. I have already installed the pressure and temperature relief valve, and just a plug for the drain. And what I will do is also install one more plug for this lower inlet, and then we're gonna fill it up with water and get this thing started and see how it burns. So I'm looking forward to seeing how well it's going to do. But before we do that, I need to get the oil delivery system set up for the waste oil burning water heater. What I'm going to do is this is a piece of 1/4-inch steel brake line, and I've already drilled a hole through the side of the combustion chamber as well as the little burn pot there, and so this fits through into the little burner pot right there, like that. And I'm just going to form this piece of steel so it comes down and off to the side here. This is the oil delivery tube. So you can see I just attached it to the side of the rim with a clamp and a little piece of fuel line to act as a little shock absorber, and so it passes from the outside to the inside, and it is just slightly angled downward so it drains, and then you can see that's where it will spew the oil out into the combustion chamber. Well, I just lit the fire, and it's going. Everything's ready. You can hear it start to suck the air in as the door's closed. And so what I'm going to do is, yeah, there we go. That's looking good. I'm going to measure the water temperature. So this is a PID temperature controller. I'm just using it as a regular temperature controller, so no PID function going on here. It's connected with a K-type thermal well inside the water jacket there. So that's going to give us a reading of the water temperature. Ignore the bottom. That's just the set point. The top is our actual reading. And so I'm going to start to feed oil into this and we'll see how it works. Okay, so the burner's been running for, I set the timer for 3 minutes now. We've gone up by 11 degrees, so we're at 23 degrees Celsius now. And the little metering pump is delivering about a second's worth of oil every 10 seconds. And yeah, it's running quite well actually. Just getting a little bit of smoke from the paint burning off on the lower combustion chamber. There's a little bit of smoke coming out the top, but we haven't reached a good high combustion temperature yet, so there will be some darker smoke, but that should clear up as it gets hotter as we continue to run. Been exactly 20 minutes since we lit the fire in the waste oil burning water heater, and we are now at 69 degrees Celsius. It's burning quite well actually. Yeah, still a little smoky, but not too bad. I would like to try and figure out how to improve that a little bit more by adding another length of pipe that would potentially increase the draft. There is also a risk of that exhaust gas cooling too much in the pipe and not providing the desired effect. But yeah, I think it would be worthwhile to give it a shot and see how that works. That would add another 4 feet on top of there, so we'd have an 8-foot chimney on top of the water heater overall. So something to think about anyway. Overall, I'm quite pleased with how this has been working out. I have mentioned previously that I do have ideas for a version 2.0. For now, I think this build will work just fine as it is. Obviously, it can heat water, and it's a good way to use up old oil. So yeah, that's about all I have for this video. It's been another longer video. And so in the next one, I would like to get into a little bit more detail on the control system, exactly how the PLC works, how the metering pump works, and then how that's going to work with the temperature controller. So the flame is out. I shut it down about 5 minutes ago, and overall, I'm quite pleased with how this has worked out. Our starting temperature for the water in the heater here was 12 or 13 degrees Celsius. It's 91 right now. It was as high as 94, teetering on 95 for a little bit there. But overall, for 30 minutes of runtime to get that up to temperature is really good. I'm quite pleased with how this has worked out. I would say it's not a perfect build. There are definitely some enhancements that I would like to undertake to try and improve the way it burns. So I find there is still a little bit more smoke than I would like, and there is also a little bit of soot or ash that's coming out. So I'd like to try and get the combustion temperature a little bit higher. So that might include adding another piece of chimney pipe. That would have the effect of increasing the draft. The other possibility, of course, is to add a fan. I'd like to try and get away from having too many components running for this to actually function. Being able just to feed oil into it is pretty straightforward. Adding a fan, it just adds another layer of complexity. So I'm going to think about that for a little while. But overall, like I said, I'm quite pleased with how this has worked out. It's a good build. Of course, many ideas that could be ported over into version 2.0, but that's for another time. So anyway, yeah, if you are enjoying the build so far, be sure to like and subscribe. Anyway, thanks for watching. See you soon.